Assalamualaikum warahmatullahi wabarakatuh. Good night, everyone. Let me introduce myself. My name is Aufar Al-fathan. I'm from numerical method 02. So here I want to explain to you about my idea in circular economy, the application of numerical method in circular economy. So my idea is waste to wealth. So I will do optimization of wealth to biofuel conversion via gasification for Indonesia's circular economy. So basically, it's about optimization of waste to biofuel energy. So the conversion is from gasification process from the waste, solid waste to biofuel gas. Okay, next. So here the content. Then so for the introduction, as I explained to you earlier, that this topic overview is about optimization to about the waste to biofuel by gasification for Indonesia's circular economy. So here I'm from mechanical engineering of Facultas of Engineering Faculty of Universitas Indonesia. And then, so for the abstract is, so this paper explore the application of numerical methods in optimizing the conversion of organic waste into biofuel through gasification. So with the focus of supporting Indonesia's emission reduction targets, so by enhancing the efficiency of the gasification process, we can approach this to contribute to the circular economy, and the country goes to reducing emission by 45% by 2030. So here I want to achieving the net zero emission by 2050. So basically, by this method, we can help Indonesia to find this to reach these goals. Also make the world a better world. Okay, next. So that's for the abstract. So it basically the unconsciousness in the E5. So in this paper, I use the E5 methods for making the solution for the problem. So basically from the start is my consciousness. So in my consciousness here, I want to talk about the circular economy concept and importance. So circular economy itself is some source of X that eliminates waste and ensure continuous use of resource by creating closed loop system. So here, the application of circular economy is into conversion organic waste is really helpful and also good for Indonesia because we have so many ways that we produce from people from 270 million people. So basically, it's a good choice to gasification from waste to biofuel. And then so in this conversion from organic waste to the biofuel, it's basically in gasification process that promising application for Indonesia, right? So basically for this waste to biofuel process, I want to make this to a better impact for Indonesia because Indonesia right now is challenged by inefficient landfill operation and accumulation of organic waste that causing methane emission and also environmental hazard. So I want to make a better impact for Indonesia for waste management so people in Indonesia can live better by their waste and also their energy that Indonesia can provide for them. And then so basically in the next method is about intention. So here I want to make this idea. Basically my intention is for the greatest for the better impact for Indonesia. And then also I want to make a better landfill management in Indonesia and also provide energy for Indonesia by this biofuel gasification conversion. So basically it's solve three and almost four problems. First is about I want to solve intention for solve the problem of landfill management. And then the second is about the energy profit for Indonesian citizen. And the third is the circular economy, that we manage our waste to make a better economy. And then the fourth is make a better impact for citizen of Indonesia by reducing the emission. Okay, so in the next thing is about the initial thinking. So initial thinking is about our first talk about this problem. So about this problem, so gasification process. So basically, gasification process is a thermochemical process that converting carbonous waste material into syngas. So it's use carbon waste, bio waste that contain carbon, so it can be converted by thermochemical reaction into syngas. So this syngas can also process it into biofuels, and the syngas component is include CO, H2, N2, and so on. So the application of syngas is used for energy generation and production of various chemical. So in this method, I use numerical method for optimization in this gasification process. So by this optimization, I want to make this numerical method is essential for improving the gasification efficiency. So the numerical method will control and prediction of variables of engine performance. And then the optimization we use linear programming and also non-linear programming and also genetic algorithm. And then for the modeling, we use kinetic modeling that describe rates of chemical reaction during gasification process. So it's basically for aiding in understanding and optimization reaction condition. So these three steps basically that I want to implement this numerical method in gasification. So what can I include is the role of numerical method is to optimize, to control and prediction for the variables and engines to make better efficiency. And then we use this optimization technique by linear programming, non-linear programming to make the calculation for optimization. And then we also need to use the modeling kinetic that to describe the rates of chemical reaction, that so we can understand it better to the next. Okay, next, it's about the idealization. I mean the initial thinking also. So in this idealization, the next is idealization for the E5. So idealization is where we choose the perfect or the perfect or maybe the best option to solve the problem. So here we can choose the problem is to maintain the optimization, right? So for this, I use the equation of the gasification optimization, and then I use constraint. So in this thing, I choose the optimized reactor condition to maximize biofuel yield while minimizing energy consumption and emission. So I want to optimize the reactor condition of the gasification. So it will be maximize the biofuel yield that the reactor can produce while minimizing the energy consumption and also emission that the reactor make. And then for the constraint, it's basically about the mass balance, energy balance, and reaction kinetic constraint, because it will be more practical for this gasification process that use fire and thermo and other things. And then for the instruction process, here I use the simulation in Python programming. So this Python programming is include the optimization code that I will show you here. Wait. So here the code for the Python programming for maximizing the biofuel yield. Here we have this function, objective function, and then this constraint. like mass balance constraint and then energy balance constraint, reaction kinetic constraint. This constraint will factorize the equation objective for the biofuel yield. And then we also need to define the bound for the variable. Here we use 500 to 1400 for the temperature, and the pressure is 1 to 33. Feedstock flow rate is about 0 to 1000. So it's about the constraint to make this equation more reliable for reality. So the initial case, I will choose 700, 0, 10, and 500. It's basically about a random number for initial guess. So the program can run basically from this initial guess. And then we include the constraint, and then the result is about a will choose the minimized amount of optimization here. So by this equation and this constraint, we can find the optimization result. It include the temperature. The operation can be optimized, pressure, feedstock flow rate, and maximum biofuel yield. So in this equation code, we can provide the maximum biofuel yield that we can produce by attempting this constraint, like the temperature that we need to do is that we need to set is about what temperature, and then the pressure and the feedstock flow rate, so we can produce this maximum biofuel yield. So here, by this initial gas, I will run this code here. Okay. Okay, wait. I think it's loading. So from this equation, we can find the optimization for this biofuel is the temperature must be around 721 degrees Celsius, and the pressure is 33 bar, and the fixed feedstock flow rate is 700 kilogram per second. So I think that this result is difficult to obtain when we make this gasification process, because like this 417 kilogram per second for the result that we need. Basically that here we need to find another constraint that can factorize this equation, so it will be make sense to implementing in this real world. So basically by this equation we can be more upgrading this equation, so it will more be reliable and the equation will be more accurate and can be implemented. So that's for the instruction for the E5 method. Okay, let me back to the presentation. So from the result, we can be discuss that this optimization method can be so potential because this numerical method is significantly optimized waste to biofuel conversion. So it will supporting the circular economy in Indonesia. And then for the limitation, as I explained earlier, that need for accurate kinetic data, and also another constraint that can be factorize this equation, and the complexity in modeling real world system. So by this optimization, this optimization will be complex to be implemented in modeling real world, because as I explained earlier that we need accurate kinetic, we need another factor constraint that factorize this equation. So there will be more constraint that we need to calculate to make the better accurate optimized factor. And What I expect that the future research will be focused on refining the models and also exploring additional optimization technique that we can be more accurate. Okay. And the last thing is conclusion. So this paper had like the crucial role of numerical methods in optimizing the gasification process for converting waste into biofuel. So by changing this efficiency and yield, this method can contribute to the circular economy of Indonesia by offering significant environmental and economical benefit. Further research and practical implementation of this technique can drive sustainable development and renewable energy production, and also supporting Indonesian goals of reducing emission and achieving net zero emission by 2050. Okay, I think that's all for my presentation today about my paper. Thank you for your attention. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.